Hello, everyone. Welcome to this project description of Group 4. Here we'll be presenting our heart rate monitoring system, like the front end and the back end. So this is gonna be description video and also a demonstration video, which is divided into two parts. The first one is the front end and the back end, basically the server side. And the second one is for the hardware side. As you can see here, we have a server and a database, and using the web app or the mobile app, we will be showing our work here. And moving to the project, let's first start with the server side. So we are using this my app or Win SCP using Putty. And you can see here, if I just insert my command to start the server. So here it is. Let me copy it. I guess it is somewhere between here. Okay, I get it. And the servers, like you can see the 3000 put, that means the servers start running. And if we move to, okay, just let me start the server. So here this is the link for like index HTML that will show the main page of our project. So if you refresh it, we can see the main page here. As you can see, our name of our product is HeartSync Pro. That means syncs with the heart rate and shows with a better quality, provides the data from patient to the physician and keep patient healthy, and we believe to live in healthier. So if we move, there is a video of our project, and this consists of our team. Three members we have: Muntasim Mamoon, Chris Mastengo, and Muntasim Alum Chaudhary is me. So Chris will be describing the backend, and me and not the backend, actually the hardware part, and me and Muntasim is working on the front end and the back end. So if you can see here that the patient login here, so it has a patient login page, a physician login page, and a reference page where you can see the video link and the GitHub link. Actually, yeah, I have opened it here. So you can see the GitHub link where all of the libraries and everything is here. You can go and check it out. And then if we press to the server link to see this, and the particle argon link, we have to press this. So moving to the patient login, first what we can do, we can register, right? So just do a name, just name, and one email, just say name one@gmail.com. So without the at and the gmail.com, it won't work. And say we save a password like name one and name one, like this. Submit shows that it has some points to make, or we have to give some provide a strong password reviewing these points. So let's just do name one, like this, and then name one. I guess it needs 8 to 10. So 234, submit. Yeah, it shows patient name. Then the name is the name actually, so don't be confused. Has been saved. Okay, so we can reset it and again do the rest for another person. And as we can see, we can go to the patient login and name one@gmail.com and name 1234. Start logging. Yeah. So here you can see the patient can choose out of 3 any physician, It has name, last name, and the email. And also make sure that last name and the first name has to have a string or not a number. And the device, you can see the device name and device serial, the data viewer, like the summary, weekly or daily, and the logout. I can show you one of the datas that I have. Let's just do, what to say? Let's just do this thing, login. Here you can see the device is already been here. The name is, device name is this, and it's updated. We already fit data here, so it's fine. So it will show the data. It will different range though. It will show the data. We have collected it to make it look nice, and then log out. If you go into the physician side, same for the registration. You can register here like the same. And if we just insert, we have one from the previous. If you insert, you can see patient view, and you can choose patient like this, where you have like one person, and also we can choose other person. I have other persons like fit in like this. We took the data, and the all patient view has all the patients here, and that we can log out. So now it's part for the backend. Yeah, let's move to the backend. For that, I need some time. Okay, so how to start? Yeah. Just a moment. You go to VS Code, and I have here the code, as you can see here. So let me start saying you the whole thing. As you can see here in the left side, here I have loaded my project here in this software, and in the module you can see the three things: physician, patient, and particle. And it has public, where you have the CSS style sheet and the images used here, logos, and the JS file, JavaScript file just shows here. The private folder contains all the HTML file that comes after the login. We keep it separate, and the style sheets are all the CSS style sheets here to make the display look nicer. And all the HTML files here, you can see represent all the pages that I have just showed. It had roots and app.js, db.js, package.json, and everything. So during our ECE 512 project, you as a user or a patient will start by signing up on our website using your email and a strong password. Once registered, you can link your account to our HeartTrack IoT device, HeartSync Pro in our case. This device will remind you to measure your heart rate and blood oxygen levels. After taking measurements, the device sends the data to our server. In case it is offline, it can store up to 24 hours, which is like offline storage. Also, the data server is a data storage using the internet. The user keeps this information safe and sound. Sorry, the server keeps this information safe and sound in a database, and the physician can see this thing from his end. And in the project, if we talk about the project structure here, so what I have to give you an overview on this. And in this project structure, the HTML files in the public folder serves as the front end of the web application, defining the structure and layout of the pages users interact with. The CS files in the public folder provide styling to enhance this virtual representation of your HTML pages. JavaScript files in the public folder contain client-side logic, handling user interaction, and dynamically updating the content of the pages. The root folder defines the server-side logic with defined files like API, index.js, patient.js, and many more. The private folder, as I already say that. Okay, so moving to the root section here. So the browser send the request to the root, and the server here behaves like it will like the server is connected to this express in by roots, and what the server will do is that after get the post request or the get request, it interacts with the database and provide the data to the user. And in the roots, we can see 3 of them will come here later. And then the module, we have, where's the module file? Here is the module file. You can see 3 database structure files. Here data is stored in this, in this format. And if we move to modules, again, where is it? It was here, and patient.js, I guess it's here. Yeah, and here we can see one of the part of the code which is very important to create, which is the create route here. And the piece of this code defines the structures or schema for storing patient information in the MongoDB database. And it includes the details like the patient's name, email, password, and the last time they access the system, their assigned physician, and information about monitoring device. And the schema also sets the default values for some fields, such as the physician's name and the device details. The code then creates a patient module based on the schema, making it easy to interact with patient data in the database, actually. Yeah. And then if we come to app.js here, we can see this thing is for cross-antigen access. As we all know, this thing is for catch the 404 forward error handler. This is the error handler. And render the error page. We use this thing here. And this app.js code configures an express web server for the this HeartTrack project, utilizing the middleware for cross-origin resource sharing that I told you, and JSON parsing, and defines routes for main API and patient routes, handling different aspects of the application. The server is set listen to port 3000, which is already showed. And then if we move to the DB here, as you can see here, the DB, which is the database, this code establishes a connection to MongoDB database named Cloud running locally on the default address. It then exports the Mongoose object, making the MongoDB connection available for use in other parts of the application. And the package.json of package.json and package.json files, like the package.json is a configuration file that contains the metadata about our Node.js project, including its dependencies. And the other file is an automatically generated file that ensures consistent dependency variations by locking them down, based on the specific versions installed during a project setup. In this case, this project setup is our whole project setup. And if we move to JS in the public here, and the patient.track, I guess I put it here. Here you can see Ajax here, and the JS is using the jQuery Ajax function to make a post request to the patient /create endpoint on the server. It sends data serialized as JSON in the request body. Upon a successful response, the content of the element with the ID RX data is updated with the message received from the server. As you can see, in case of failure, it updates the same element with an error message. Additionally, it contains a conditional statement checking if the error output element exists, in which case it resets its content to an empty string. So yeah, and then if we move to the roots again, I have already opened it. If you see here, so in, I guess it's patient.js. No, it's yeah, it's patient.js in roots. And here, one thing we have to see the post request. Actually, here you can see the post request here. Okay, here the post request. Here, actually, the handler of Express.js post request to the create endpoint for patient registration. It first, what it does, I'm explaining it. First checks if the patient with the provided email already exists in the database. If so, it returns a response indicating that the email is already in use. If the email is unique, it secretly hashes the provided password, which makes it very powerful password. Here you can see. And then upon successful registration, it reopens with a 201 status, message configuring that the patient information had been set, which I already showed you. And moving to the next part, the patient account. I guess I have opened it or not. Okay, let me open it. It is the patient account here. Here, in the patient account, you can see that the code also uses the AJAX request, and the server endpoints are patient.status, and this is a get request. The last one is post, this one is get. So that's why I'm explaining this one to retrieve patient information from the server. This last one was to upload data. This one is to get data from here. The things are the same, but the requests are different. And if we move to the patient data viewer in JS, so here you can see a function that is the weekly report function, which fetches the weekly patient data using Ajax. So organizes the data for the bar chart plotting and dynamically creates a bar chart using chart.js. The chart displays mean, and max values of the heart rate and oxygen saturation level. And the function utilizes the chart.js library to generate these things, and visually we can see the charts. I have already shown you the chart. And now it's time from the back end. We were in the back end at the time. Now we'll go to the front end. Okay, so the front end, the main file is the index.html. Here you can see this HTML document serves as the main web page of our project. It uses the Bootstrap framework for design consistency and responsiveness. Okay, what responsiveness means? Actually, we can what we can do from this is that we can change this thing. Like let me go to the server, and if we make it smaller like this, just look how it changes with the space. Like we can use this thing by using the mobile phone or something like that. This works. This is actually works with this, and all the things get small or bigger according to the page length. Yeah, and then I guess, yeah, open the VS Code here. So the body contains all of the like the project description here you can see, and the description of individual persons you can see here, and then it shows all of the bundle JavaScript bundle here, and the template JavaScript here you can see here. And in the login patient here, where is the login? Yeah, in the login page, here you can see the same things. And the HTML document represents the login page for the patient section of the HeartSync Pro project or device. The page includes a navigation bar with links to, like you have seen the home, patient login, physician login and reference, and features a well-designed login from email and password, and it shows what to fill. Yeah, and this concludes the whole part from this end, and Chris will actually give you a basic understanding and show the device and how it works, everything in his part. So yeah, and that's from my side, and Chris will take over. Thank you so much for listening.
Okay, this is Christopher, and this is the code for the particle argon. So in the beginning, we define the data structures and variables for timing. And then here in the setup, first we subscribe to the webhook. We check for the particles sensor if it's connected. And here the sensor setup. Then here in the loop, we start with timing. First, we check if the particle's connected and if the offline data structure is empty. If it's not empty, we publish the offline data by calling this publish offline data function, which will be explained further below. Then next, we check if the current time compared to the last time is greater than 30 minutes. And if that's true, we set the reminder to be true, which flashes the LED yellow. And then we collect and handle the data, and we update the last data measurement time. Then if the reminder is active, of course, we flash the LED yellow to remind the user to take a measurement. One of the functions called above was to collect and handle the data, and that function is right here. This actually was given in the class activity, and the only updates to this are that after the data is taken, we flash the LED green to show the user that their measurement was a success, and then we turn off the reminder, which was the yellow flashing LED. Another function called above, when we first check if the particle is connected and if the offline data storage was empty, here we have the publish offline data function, which just publishes this string data when this above condition is true. And two more functions are just the flashing yellow and the flashing green LED. Then the last section of this was setting up the webhook. And here we have the name of the webhook and the event name that triggers the webhook, which is HR, that's our heart rate. We are sending to our server with the API particle data. It's a post type request in JSON format, and this is our device name. This is the custom JSON form that's sent to the server. And that's it for the particle hardware code.